Push that rock here with Simpson Math. Let's talk statistics. Statistics has two meanings. First, it's the science, art, or study, however you want to put it, of using data to improve decisions. And we do that by studying statistics. So the other meaning of statistics is important. This is how, when you hear statistics, you usually just think of the class or the study of. But it's the study of what? It's the study of statistics. What is that? Well, you might just call it data, but more specifically, and in this class, we define it as a value, and I purposely did not use number there, but a value taken or generated from a sample. And it's generally a number, but it doesn't have to be. It will be in this video, but it doesn't have to be a number. But any value taken or generated from a sample is a statistic. And when we study the statistic and use it to improve our decisions, we are doing the science or art of statistics, the course. So, what is a population? A population is an entire set of interest, like maybe everybody that's been infected by COVID. And then a sample is a subset of that population. So it's hard to study everybody that's been infected by COVID. It's really hard to study that because lots of people just stay home when they're sick and they don't go get tested. And then even when they do go get tested and they're tested positive or negative, there is a slight chance for error due to the diagnostic tool having a slight chance for error. We'll study that later. It's called sensitivity and specificity. So anyway, a population, an entire set that you're interested in, and a sample is some subset. So throughout this class, we're going to use this metaphor of a balls in an urn, okay? So we have all these balls in an urn, and these balls could be everybody infected with COVID. And some of them are, present no symptoms at all, and others present symptoms. So maybe present symptoms and not present symptoms. They're black and white. Or maybe they're hospitalized, and maybe they're not. So people not hospitalized, people hospitalized, whatever. There's two characteristics represented by the color of the balls. And we could have more colors in there, so we could divide it up in more ways. Now, a parameter is a value taken or generated from the population at large. So maybe we want to know the percent of people that are hospitalized if they have COVID. And it may be hospitalized is the black balls, and white balls are people not hospitalized. And so we want to know the percent that's black. That would be a parameter. But it's really hard, usually, to get a parameter. You have to take what's called a census. A census is taking a measurement or an observation of every item in the population. So we'd have to go find everybody that's ever been infected by COVID and find out if they were hospitalized or not. And that would be really hard to do. So we almost never can take a census. The American government is heroic. They try to take a census every 10 years because their Constitution says take a census. So they do their damnedest to take a census. And every once in a while, some statistician says, we should amend it and say, let's just take a sample. And the originalists that want to not change the Constitution say, no, we're going to count everybody. So we spend a lot of money trying to count everybody. And it may be useful. I don't know. But that's an example of a census. But usually what we do is take a sample. So imagine shaking this up and randomly pouring some out. That would be generating a random sample. Or maybe we just go in and grab some off the top. That would be grabbing a cluster, those that are on the top. Or maybe there'd also be convenient sample because we just grab the ones that are easiest to get to. Or maybe we just divide some up into hospitalized and not hospitalized, like those that were tested positive but stayed home and those that went to a hospital, and then we take a random sample from each one of those. That would be creating a strata, making sure you get both from each kind. But anyway, there's lots of ways to take a sample. Let's imagine taking a sample. So we get this sample, okay? Now, this information that we're gathering, you can call data, but I'm going to use the words measurements and observations a lot. And in this class, we're frequently looking to see, we're observing something and comparing it to what we expected. So like maybe we expect 1 in 100 people to be hospitalized. We take a sample and observe and see if that's true. We're going to do a lot of that. So we observe here in this sample that there's 1, 2, 3, 4, 5 whites and 1, 2, 3 blacks, okay? And a statistic, remember, is a value taken or generated from a sample. So an example of statistic would be the proportion of black balls. And maybe that's the ones that are hospitalized or the ones that presented symptoms, however we categorized it. And the proportion here is 3 out of 8. So that's a statistic. And we use that to infer something about the population. Like, does that mean that 3 out of 8 people that get COVID are going to be hospitalized? That's a big guess. We're trying to guess that all the time. How well prepared do the hospitals need to be? If it's really 3 out of 8, that's incredibly high. Well, then we're really going to be in a world of hurt, which we kind of are. Okay, but that's an example of statistic. Another statistic would be a count, when like the black showed up 3 times. So 3 is called the frequency, the count of the number observed. And we're going to look at a lot of frequency distributions this semester, and that's any kind of display whatsoever. In fact, this one even counts. This display counts as a frequency distribution because you can see here that there's 3 out of 8 that are black and 5 out of 8 that are white. So any kind of display at all that shows all the frequencies of whatever you're studying is a frequency distribution. So here's another example, a famous bar graph, not to be confused with a histogram. But this is a bar graph because it has categorical variable, see the next video, categorical variable on the horizontal axis. They're either black or white. They're either hospitalized or not hospitalized. And the frequencies on this vertical axis, and there were 3 blacks and there were 5 whites. Now we can quickly turn this into a relative frequency distribution by dividing by the number in the sample. So this becomes relative to the entire sample. 3 out of 8 were black. So that's a relative frequency distribution when the vertical axis is a relative frequency. Or the method of display is showing relative frequency. So another relative frequency is a pie chart. So here we have 3/8 of the circle sectored off. So it's 360 degrees. So I divided 360 by 8, got 45, multiplied by 3, got 135. So this is 135 degrees. So 3/8 of the circle is black, so it represents that relative frequency that I saw in the sample. Okay. Now, the last thing to mention before I end this video is we're always trying to minimize sampling error. And what is sampling error? Well, it is error that is caused by just the technique of sampling. Now, there's other types of error that can be introduced that makes this even more complicated. But in theory, if we made no other errors, then just the act of sampling will create some error. And you generate a statistic and you subtract the parameter. In this case, our statistic was 3/8 were black, okay? And then you subtract off whatever the population is, and that creates some small difference. Maybe only 1/4, so 2/8. Maybe, we don't know. This is a question mark. But say it was 2/8 of the population are actually going to get sick and have to be hospitalized. I mean, we're all going to get sick if we get COVID slightly, but maybe only 2/8 are going to be hospitalized. So then the sampling error would be 1/8, okay? Well, this is pretty big. This is 12.5%. That's a pretty big error. And you always want to, when you're sampling, you want to reduce whatever this is. So you want to work really hard to make sure your sample represents the actual population. So you don't want to walk into a hospital and ask everybody inside the hospital ward that's being treated for something, hey, have you had COVID and have you, been hospitalized for it? Because then you're more likely to get a lot of hospitalized patients. I mean, there may be somebody in there for a heart attack that says, yeah, I had COVID, 3 months ago and I was fine. But most of the people that if you go in the hospital, you're going to get a lot of hospitalized COVID people. So you want to make sure your sample technique is such that you reduce the error. And the way to do that is you want your sample to be as representative as possible of your population. And your goal is to reduce this. Now, you won't ever really know what it is because you don't really know this, so you can't really subtract this off and generate this number. Math made simple. Simpson math.